you guys might have heard that the standard model of physics is it's being shaken to its core.
Oh no, what's happened?
Lots of
Drama
sound.
in the physics community?
Oh boy, you betcha. So much drama. Brian Cox, he has gone nuts. No.
Old tweets been dug up.
No, so
The standard model has been cancelled. And actually that is true. The
No.
standard model might be cancelled.
okay. It's not necessarily been cancelled. Necessarily. We'll get to what
It's
specifically.
been shown to be problematic. That's also true.
A long
Sure,
history of
it's
bad
been
behavior.
problematic. It may have been shown to potentially be problematic, and now it needs to address its behavior and grow from that.
Yeah.
You know, Luke, do you know what a muon is?
I do. It's like an electron, but it's heavier.
Do you know how many times heavier?
Many.
Yeah, about 207 times heavier. And you say they're like electrons, that they're charged. Is generally what people mean by that. So charged like an electron, but very, very heavy. I mean, say very heavy in comparison to an electron. Still
very light
very
compared to me.
compared to most things. Compared to pretty much anything, it's incredibly light. And not unlike, I feel bad for saying this already. Not unlike Luke, muons are also relatively unstable. They basically last for about 2.2 microseconds before they decay into electrons and neutrinos.
Just like me.
I mean, sure.
I think the joke's running thin.
You probably got just like me. You probably got some muons running, kicking about inside you there, mate. No, there's recently been an experiment involving muons, and we've kind of got some hints that there might be something going on outside of the standard model. So the standard model is essentially this. It's the standard model of particle physics. It's basically the ideas that we've built up at the start of the 70s. We started developing the standard model, and it's just these ideas sort of built up on each other. Basically, what we think is going on with particle physics.
Big things.
Big things.
Big things that aren't small things.
Yeah.
Hmm.
Yeah. It's kind of like the theory of evolution, but the physics version, right? Let's think of it like that. It's how we think physics works.
Cool.
And because of this experiment, we might be a little bit wrong in some areas, or we might have stuff that we need to add into it. And basically, what's happened is we've been measuring muons. I say we, some smart scientists off in a lab somewhere.
Not us.
No, definitely not us. Pulling out our rulers. They've been essentially they've been measuring muons. So as muons have because they've got charge. When you apply a magnetic field, they'll spin. And we've noticed that they've not been spinning quite the way that we'd expect them to. And this isn't the first time that we've noticed this. We noticed this back in 2006, actually. But the issue was that we weren't quite sure if it was just a mistake or if, they've actually been spinning weird. So there's this lab in Illinois that has done similar experiments to what were done previously, and have now got a much greater degree of certainty. So this is why you're hearing about this all now, that the standard model might be overturned. There might be like secret hidden particles, secret hidden forces affecting physics, because we might have gone a step deeper. And I think that honestly, particle physics, quantum mechanics, this is a really interesting area because it feels like pretty much everywhere else we are in science, we've kind of gone pretty far. We don't feel like we're on the verge of any like extreme major breakthroughs anytime soon. But with particle physics, it feels like we know a lot, but also there's so much we don't know that we're always on the verge of a major breakthrough. Another finding the atom sort of thing, which I'm really looking forward to. And this could be that. So essentially, they measured the spin. They noticed that there was a bit of a difference, and what they think is happening is there could be a number of different things. One of the theories is that there are particles that are coming into existence and completely disappearing out of existence, like almost immediately. Pretty much, they're basically, yeah. You look a little bit shocked here. It's pairs of particles that come into existence. So one particle will come into existence at the same time as its sort of anti-particle.
Yep.
And they essentially then cancel each other out. From what I've read, these particles can just come out of just space. But then that's kind of how electrons work, from my understanding anyway, in that they can be there's no sort of one place. Like when we think of electrons as sort of orbiting around the atom, right? But that's not actually what they do. They kind of just there's a probability.
As a cloud.
Yeah, there's a they don't even. The thing is, when we say they exist as a cloud, that's also confusing as well, because they exist as a probability cloud where there's places where an electron is very probable to be and places where it's unlikely to be. But there's no sort of this is exactly
Where it is.
where it is.
Right.
So it's very confusing. But essentially, these particles exist very briefly. They come into existence, then sort of come out of existence almost immediately. But they can affect how actual sort of real particles, let's say, behave. So they think that essentially what might be happening is that there are these sort of virtual particles that are appearing then disappearing that are affecting muons. But also, it's not just known particles that could be appearing; it could be unknown particles, things that we have no idea what they are, which could be causing these unknown effects. So that's just one idea. But there's also the idea that there could be this invisible force that we're not aware of. So we know of sort of like four sort of fundamental forces right now. Do you guys know what any of them are?
Gravity, weak
Mhm.
force, strong force, and flip. What's the other
Medium force.
one? Electromagnetic force. Yeah.
Dead on.
Yeah.
Very good. Yeah, no, exactly. So there's those four forces, and we think there might be potentially another one. But again,
What does it do?
don't know.
Oh.
No, honestly we don't know. We would know that it would be affecting the muons and making them say spin faster than we're expecting. And there's also this thing with muons as well. This interesting thing where there was another study I think a couple weeks back or maybe a couple months ago on muons as well, where essentially what happened was they were measuring sort of how they decayed. So I've told you already they decay into neutrinos and electrons. But I think we were getting more electrons coming out than we'd expect and fewer neutrinos. And so they were trying to figure out what was going on there. And this could be the same thing. So a very smart scientist has said it may be the same physics from a different angle, or maybe it's different physics in regard to the muons decaying and spinning. So we basically at this point we don't know what's going on. But what we're doing is we're trying to recreate these experiments so that we could see if the sort of difference in the spin that we're measuring is a mistake, which it could be. But we're getting to the point where we're pretty sure that it's not a mistake, or whether it's like something that's actually affecting the universe essentially. So you'll probably be hearing very soon that this was nothing, or physics has been slightly upended. In that they're basically they might add another force, they might have a new model that they're working on. This is really similar, I think, to do you remember when we thought that we'd broken light speed?
No.
Yeah.
Do you not remember
so
that?
there was this story where there was a specific type of particle
I think it was neutrinos.
that that appeared to be going faster than the speed of light, and it turned out to be a measurement error.
Yeah, exactly. But it's really hard to measure these things because they're very small and very fast. And when you're sending something, I think they were basically sending neutrinos through the planet from sort of send to a receiver. And obviously, because the time intervals for these things are minuscule, if you measured off by a second,
Yeah.
that would be more than the time. Like that'd be massive, right?
Yeah.
So a tiny little measurement error could be an issue. But the thing with this is that they've repeated it in 2 different labs, and the second lab they've done it in was much more precise than the first lab. So we're getting to be pretty sure that this sort of thing with the muons could actually be a new sort of view of physics. But then don't take it for granted. Don't take it as fact though, because again,
We
don't
broke
know
light
yet.
speed, didn't we?
Yeah, exactly. We thought we don't know yet, and that's essentially what's going on. It could explain the expansion of the universe speeding up, because we've kind of spotted that. We don't really know when that's happening. It could be because of this. Again, we don't know. So if you're reading this in the papers, which they've all been talking about this,
Yeah.
essentially what they'll be saying is quantum physics, particle physics might be different, but we don't know.
Love that.
Things like this are always funny to me because in the kind of way our world is structured, you have this idea. I forget the name for it in economics, but basically you have this idea where like you do your task very well. So you learn how to do your task, and you also trust that other people know how to do their task. So then you don't know how to grow crops or something. You don't know how to drive a truck. Someone will do it, and then you all work together, and we all work through money, and it all works very efficiently, right? And it's one of the reasons our world is so efficient. And so when you're growing up, you're sort of not encouraged to think about some of the things you might naturally then think about because you're encouraged to specialize. Like you go and work as a musician, Jamp, you go work in video, Corry, you go work, well, it's kind of in science.
The sting!
And so you kind of feel like, oh, well, I don't need to know how Wi-Fi works because somebody does know how Wi-Fi works. I don't need to know how the universe operates because somebody does. And then it turns out that kind of nobody does. And this, like moments like this are always really interesting reminders to me of the fact that there isn't anybody who actually understands how the world works on the most fundamental level. Like we're still figuring that out, and we might never figure it out. But we're still kind of getting there. And every so often we think we've got it, and we're like, our model hasn't been broken for 30 years. It must be really good. And then we go, oh, and then the whole thing
Never
gets
mind.
thrown out, and we have to start again.
Yeah.
It's so fascinating and so scary.
I think what's interesting is that I feel like people don't necessarily, and I think we've spoken about this before, I think that people don't necessarily get that there is no end point to science.
Mhm.
It's not like you're running a race and the first to get there wins. It's you're like every single time you take a step, the track increases in length.
Yeah.
Like by more than you step forwards. Like the more you know, the more you realize you don't know.
I think terms like the theory of everything really make the average person think that science does have an end point.
Oh,
Yeah.
yeah.
Like, the theory of everything. Okay, once we figure that out, that will be it for science.
That's everything.
And we'll do something else. We'll do poetry.
And
But
then we'll get the science of poetry down so great that like we'll make the perfect poem. You'll just cry
No, we
Everything
every
poem.
time.
The everything poem. That's it.
the AI will make the perfect poem, Corey.
I mean,
No, it
honestly,
won't.
right now the poems they're making are not that great.
Oh, they're better than some people's poems.
Oh, I mean, can you imagine, right? At some point in the future, when AI is making films, not just
Oh,
just
God.
writing them,
My job.
Like generating the pictures.
generating everything. That'd be, or you could just plug in. You could just type in,
Yeah.
"I want a film with Ryan Reynolds and
Oh,
Ryan
God.
Gosling and Ryan Seacrest."
Directed by Ryan Coogler.
Yes, exactly.
Yeah.
And and the AI will be like, "Okay, cool. This is your film. Shot, everything done."
It's called Ryan.
Yeah, there's some really interesting stuff in one of Yuval Noah Harari's books where he talks about how a AI will know exactly how you're feeling and will know how to construct a piece of music or construct a TV show that specifically takes you on the specific emotional journey, not even that you want to go on, that it thinks you should go on.
Mm.
And like the level of it's so exciting. Anyway, this is away from
Is that
Muons.
Sapiens?
No, it is
other one.
21
How many days?
lessons for the 21st century.
Oh, the third one.
Oh.
Yeah. Oh.
It's interesting though. It is interesting, and this is the thing. That's why I really like this area of physics, because it feels like we're on the precipice, and I often I feel like we're at this point in science in many other areas where we know a lot, but we don't know. It doesn't feel like we're on the verge of anything
Mhm.
major. We could discover aliens. That would be great. But it doesn't feel like we're quite there yet, We're not at the point where we can send lots of people to Mars. We're not
So
quite
we
there
haven't got
yet.
anyone to Mars yet.
Within within 2 centuries, within 150 years, we went from not being able to fly
Mhm.
to putting people on another planet.
On the moon. Yeah.
Just-
and now Mars.
Yeah, it's insane. It's insane how quickly things go by. But yeah, that is the story about muons. Essentially, we think we might have cracked new physics, but we don't know yet.
Stay tuned.
We're getting surer by the day.
And also
One
less
day.
sure.
Well, yeah, and also
Oh,
less sure. Don't tell them that. Don't let them know that. If you enjoyed that clip, head over to patreon.com/Sci Guys, where you can find the full show. Or you can stay here and catch up on old Sci Guys episodes. Or you can follow us on Twitter, Instagram, and Facebook at Sci Guys Pod to find out when we're doing more live shows.